that we're going to be working within the assembly file within our Onshape document here. And so I have 3 parts. Those parts are open. I am in the assembly file. And so I'm going to go ahead and come up here and click to insert some files into that assembly. I have a bracket, a pin, and a wheel. I'm going to go ahead and click on the bracket part. And I'm going to click to add one instance of that bracket part to my assembly file. Then I'm going to click the pin part and click to add one instance of that. And I'll go ahead and click the green check mark, and I have those 2 parts here. You can notice that you can click and move these parts around, and so they all right now have 6 degrees of freedom, both of the parts do. And so we're going to be using our constraints within Onshape to limit those degrees of freedom so the parts interact how we want them to. All right. And so over here we have all of our constraints that we'll utilize within Onshape. So the first thing I'm going to do is I'm going to click this first one, which is the fastened mate constraint. And so I'll go ahead and click that, and I'm going to zoom in here to my pin part. And notice how I have that orange circle selected, and then I have a coordinate with the blue line coming out of it. That's showing up. So what that is doing, it's referencing the center of that cylinder and the outside edge of that cylinder. And so when I have that, I'm going to go ahead and click, and then I'm going to come over here to my bracket part. And what this is going to do is that circle on the cylinder that I have selected and this circle that I'm going to zoom in and select on the bracket part are going to touch each other, and those centers are going to line up because the center of that hole is selected. All right, so I'll go ahead and click to do that, and you can see that the part did exactly what I wanted it to do. Those 2 circles are touching each other, and the centers are lined up. It is in the wrong way, so we need to flip that. And so I'm going to go ahead and click this button here to flip the primary axis. And then I'm going to go ahead and click to finish that constraint. And so what that did for us is it put that pin into the hole, and it's fixed in that hole. All right. And so if I come over here to my mate features, I'm going to right click on that and say edit, and it'll bring back up that constraint window. If I click this play here, it will animate the degrees of freedom that are in that part. And so if I click to play that, you're going to see nothing happen because we've taken away all of the degrees of freedom with that fastened mate. On the drop down, I can change the different types of mate constraints here. The second one's a revolute mate, and so I'm going to go ahead and click revolute. It will change that to a revolute constraint. And now I click that and see how it will rotate around those centered axes. So there is 1 degree of freedom within this part. The next one is the slider mate, which is right here. Again, I'm going to select it by clicking the drop down and selecting slider. If I click the play button on this, notice how our part will slide back and forth, and it will also rotate. And so other things I can do is select the limits here, and I can put in minimum, maximum values for those limits, and that will allow you to do some other, allow it to not move in and out past the object. So if you have a stopping point, you can put those in here. You can also offset in whichever direction you want, and so this would be offsetting in the x-axis, and so I could put in 10 millimeters, and it would move that part over 10 millimeters in the x-axis, and so that's what the offset will do for you. I'm going to go ahead and put it back to 0. I'm going to come back up here to slider, and our next one is a planar mate. And so I'm going to go ahead and click planar, and then I'll click the play button so we can see what that does. Basically what the planar mate does is it puts those 2 circles that we selected on the same plane. All right, and so they will always be in with one another, and we will have 3 degrees of freedom on our part. So our part can still rotate, and it can move in the X direction, and it can move in the Y direction. Again, you can change those limits right here with the clicking limits, and you can change which axis it rotates about right here. So if we wanted it to rotate around the Y axis, I could select that, and we could see what that looks like. So that's the planar constraint. The next one is the cylindrical mate. So I'll go ahead and click the cylindrical mate from here, and let's see what that looks like by hitting play. Notice now our part rotates and it slides around that axis. And so I can see that it rotates and translates back and forth along that. And so that is the cylindrical mate. Next one is the pin slot mate. So I'll go ahead and click that. Click the play button, and I can see that now I'm rotating, and I am also moving along a translation. And so that is a constraint you can use if you have a slot and a pin that needs to rotate within that slot. Next one we have is the ball mate. So I'll go ahead and select that one. And again, I'll hit play to see what that looks like. And so basically what this one has done is it's put those 2 center points where they're connected. It has put those 2 things together. And so we can rotate around that, those points, but the rest of it is fixed. And so all it can do is rotate around. And so those are the basic mate constraints that we will utilize within Onshape. I will go ahead and select, because we want this to rotate, but we don't want it to slide back and forth. So a cylindrical mate wouldn't be correct. A revolute mate would be what we wanted for this. And so I'll go ahead and click the revolute mate. This part turns. It has 1 degree of freedom left, a revolution, and that's it. So that's just a quick overview of the types of constraints within Onshape. The thing we're going to do is put the wheel on this pin that goes on our part. And so if we look at this from the right side view, we want the wheel to be centered between these 2 faces on our bracket. And so when we click to add a mate to it, we notice that we get that center of mass symbol and our axes that we can option with. In this case, we don't have an axis available in the center of that pin. And so we're going to add a mate connector to that, and that mate connector will allow us to select the center of it. And so when I click the dialog box for that, I have some options. I'm going to say that I want it to be between entities because we want our new mate connector to go between these 2 parts. And so I'll say between entities, and I'm going to go ahead and select this face. I'm going to make sure I'm on the center of it with the mass, center of mass indicator. And then for the between entity, I'm going to select this face. And so we want that connector to be right between those. And I can go ahead and then click that green checkbox, and you can notice that we've added that mate connector right to the center of our pin where we want it. The next thing we're going to do is apply the mate constraint to that. And so we want this wheel to spin around that pin. And so I'm going to use that revolute mate again. I'm going to go into where I am selecting the center of our part. To move around until you feel like you have the center of that. I feel like this is the center of that part, and then I'm going to go ahead and select that constraint and put those together. I can look at it and it looks like that is correct, and so I'm going to go ahead and click the green check mark. And when I do that, I can see that that revolute mate that I've added I'm going to right click on it and say edit, and then we're going to play it. And notice how it rotates around the pin, which is good. Now, this isn't really the true motion of it because it will still translate along the pin as well. And so how I can fix that in my constraints here in my mates is I'm going to go ahead and select, instead of a revolute mate, this time I'm going to select a cylindrical mate, which will allow it to rotate and translate around an axis. And so if I click that cylindrical mate and then click the play button, I can see that my part rotates and also translates on that axis. Now, when we look at that again, it goes past the part, and so we want to set some limits to that. And so I've measured this part already, and I know that I want the Z minimum translation to be -5 millimeters, and I want the maximum to be 5 millimeters. So if I put those in and then I select, go ahead and hit the check mark, and then I will edit that cylindrical again. Notice how it moves back and forth, and this time it stops at those limits that I've added. And so this is a true representation of how we want the part to behave. Next, I'll go ahead and hide that mate connector so we don't see that anymore. And then we're going to add some standard components, some bolts to our assembly here. And so I'm going to go back to the insert, and instead of current documents, I'm going to click on standard content. All right. This will give you all different types of bolts and fasteners that you can add to your assemblies. In this case, I'm going to select an ISO standard. I'm going to leave it as bolts and screws. I'm going to change the class to hex head bolts and screws. And then I'm going to look at the component, and we are going to make it this grade A&B ISO 4014. From there, I can select the size of fastener I want and the length. Now in this case, if you don't know what size of fastener you need, you can select this tool here and click on your holes, and it will tell you what size of fastener you need to go into that hole. And so in this case, it's selected an M10, which is a metric unit, a 10 millimeter bolt. And so that's what we'll use with our component. It has a length of 45 millimeters, and the thread length is also 45 millimeters. You can also change the material here. I'm going to leave all that the same right now, and I'll just click to insert. And I'm going to go to a top view. I'm going to undo that real quickly. I'm going to go to a top view of my parts first, and then I'll click insert. And then I'm going to line up the bolt with these holes. And if I do that, I can see that my bolt goes right into the hole. And so I'll do that again, insert another instance of the part. Make sure I have that, again, center of mass selected. That's the correct for the hole and also for the bolt. When I'm done with that, I'll go ahead and hit the green check. I can see that the bolts have been applied to my design. And I am finished here with this assembly. Again, if you wanted to edit any parts of this, you can edit the parts here, and you can edit the mate features here. And so let's say this is the wrong size of bolt. I can simply click on it and select Edit Standard Component Instance. And let's say it was supposed to be instead of a 45, it was supposed to be a 55 millimeter bolt. I can just select 55, and then I can update, and it will change the length of those bolts to 55 millimeters. So that is the basics of assemblies.